This is a brief video about angles in parallel lines. It's important to be able to name angles in parallel lines so that you can identify the type of angle you're dealing with. I'm going to talk about three different types of angles we can see, and those angles are corresponding, which look like this. If I've got an angle here, the angle that corresponds to it is over here. We call them corresponding because they match up relative to the line that runs across the middle that we call a transverse line. Transverse literally means across lines. So this line runs across the other two, and we call these corresponding angles. Of course, that's not the only set of corresponding angles here. I could have identified those two as corresponding, or those two as corresponding angles, or those two could have been identified as corresponding angles. If we want to look at alternate angles, we are talking about angles that are on the alternate sides of the transverse line. So on the inside of the parallel lines, this angle and this angle are alternate. There's another set of alternate lines. I've deleted them all again. The other set of alternate angles is those two angles just there. Co-interior, if we think about the interior part of that, are angles that are inside one part of the parallel lines. So this angle and this angle are co-interior, and this angle and this angle are co-interior. So what's so special about these things? Well, if the lines are not parallel, there's not much special about them. If they are parallel, then there are some special things about these lines. When I have two corresponding angles, they are equal. So if I knew that that was 120 degrees, I'd know that this was also 120 degrees. The same is true for alternate angles. If I have an alternate angle here and an alternate angle here, if that was, for instance, 40 degrees, then we would know that this one was also 40 degrees. Co-interior angles are not quite the same, and we can see that they do not look the same, but they do add up to 180 degrees. We can tell that from the corresponding angles. If we just quickly go back to the corresponding angles, I said that this might have been a 120 degree angle here. That would mean that this one was also 120 degrees. On a straight line just there, that would make this 60. So on the straight line, this adds up to 180, and since this is the same angle as that, because they're corresponding, the angles on the inside of parallel lines always add up to 180. So if I knew that this was 60, I could work out straight away that that was 120. If I knew that it was 40, I could work out that the other one was 140.